All right, so the first thing I would like you to do is, as a pod, come up with 3 separate graphs that go through A and B, but they need to be continuous and differentiable between A and B. Come up with 3 separate graphs, and then I want you to discuss what all of these graphs have in common. Okay. Draw one else that looks different than what the picture will be. Draw one else that looks different than what the picture will be. Each pod has a marker. I want 6 different graphs up on the board.
Maybe they are though.
Math graph doesn't be artistic.
Oh, it's not.
I was just trying to actually.
Who drew the one in the top left?
Me?
Alright, come on, Will.
Alright,
I'm actually surprised that there's not.
I was gonna draw an ellipse, but I'm like, that's not smart.
You were right. I'm actually surprised nobody drew just a horizontal line. But that's okay. We don't need it.
It's not basic.
You're not basic. Alright. All of those graphs, what is one thing they all have in common? The second. Well, that is a point. They're continuous and branchable. They go through A and B. What else? We are in calculus class. Maybe you can consider some calculus. I just highlighted some points. I don't have enough time to do CJs. I'd have to put up a lot of points on CJs. Why? What am I highlighting there? Okay, and what are the slopes there? 0. No matter what kind of curve I draw through these 2 points, at some point we have to have a slope of 0. If I drew a line, what would the slope be? 0. Okay, this is actually what we call Rolle's theorem. Okay, so I'm going to come back to this picture as you write the word Rolle's theorem. Okay, A and B, what's true about their function values? What's true about their height? It's the same. So what's the difference between the height of A and the height of B? 0. So since A and B have the same height, there is going to be a curve where at least one number in between A and B will have a slope of 0. Now, why is it important to talk about continuity and differentiability? Okay. Without the continuous and differentiable piece, this is not guaranteed. So it is going to be important to consider whether our function is continuous and differentiable before we talk about Rolle's theorem. But what this is saying, and this is what I tried to have you demonstrate with your pictures, if A and B have the same function value, then somewhere between A and B, there's going to be a time where the slope is 0. Whether we have a crazy curve that has lots of times, or just a simple curve that has one time, or we draw a straight line and it's always 0. But no matter what, between A and B, there has to be a time where the slope is 0. No matter what. Guaranteed. Okay? So what I'd like you to write down is this interval. So this function, x squared minus 2x. I want you to write down the interval -1 to 3. Okay. And what I'm asking you to do is show that there must exist a c value where we have a derivative of 0. Okay? So, this is asking us to demonstrate Rolle's theorem. What needs to be true about the function values? They have to be the same. So that's probably something that we should check. Okay? So let's go ahead and check that. What is f of -1? What is f of 3? Okay, so that's good. We are at the same height. Okay. We also better check to make sure that this is continuous and differentiable. Now, we need to be continuous on the closed interval. Okay, that's pretty easy to check because we have a polynomial. A polynomial is always continuous. Do you agree? Okay. Differentiable. We only care about differentiability on the open interval because it could be a function that has endpoints. So we're not going to worry about the endpoints. I just want to worry about in between the endpoints. Are we differentiable between -1 and 3? Yep. Or a polynomial. Better be. Okay. I am asking that you actually write this down. Continuous, check. Differentiable, check. I need to know that you actually thought of those things. Okay? So when you do these problems, I need you to physically write this down. We do have function heights that are the same. So how are we going to determine the x, in this case c, okay, the x value, which we're going to call c, that has a derivative of 0? What are we going to need to do to find that? Find the derivative and figure out where it's 0. Okay? Our derivative, Will, what is it?
2x minus 2.
And if we want to know where that derivative is 0, it would be x equals 1. Is that value in our interval? That's what we're looking for. That's bad, right? Okay. Please write down this function and interval. Okay, so we need to think about first, are we continuous and differentiable? Are we continuous? Are there any holes? Are there any asymptotes? Are there any breaks? Okay, no, there are not. Since it's not rational, we're probably not going to have to worry about that, right? Okay, differentiable. Is this differentiable?
Not all the time.
Where is it not?
Guessing at 0.
You're guessing at 0. Let's talk about the derivative. The derivative is 2/3 x to the negative 1/3. Can we plug any number into that derivative? What number can't we plug in? We can't plug in 0 because this x to the negative 1/3, that's really like x to the 1/3 in the denominator. We can't, here, I'll write it for you. We can't divide by 0. So this function is not differentiable at 0. So we cannot apply Rolle's theorem. Okay? I think this might have been a graph or a graph like one of the ones that we did for curve sketching. Does anyone remember what it looks like?
That's almost like Zoom.
It kind of looks like a bird, right? Like how we used to draw birds in grade school, right? You know what I'm talking about? Or we still draw it that way? Okay? So we're not differentiable right there because there's a corner. Okay? So we can't apply Rolle's theorem. Okay. So, next one. Oh, I don't really know why. So, next we have the function f of x is x to the 4th minus 2x squared. We have the interval -2 to 2, and you know what? I'm going to let you do this one without my guidance, because I think you can. So work together at your pod to come up with an answer for me. Are we continuous and differentiable?
Yes.
What are our function heights? Eight? Okay. CJ, why is it important to think about the function values?
Because they have to be the same height.
They have to be the same height in order for this to be 100% true. Okay? So then you found our C values to be what? Yep.
-1, 0.
You agree with CJ? Okay, they all are in the interval, so we can keep them all. There could be a time where maybe you would get like -4, 0, and 4. Well, then you would only give me the value of 0 because that would be the only one in the interval. But the cases we've seen so far, they've always been in the interval. Okay, now this is actually a special case of the theorem that we are going to talk about next. But I like talking about Rolle's theorem first because it's very visual. Okay, we can imagine what's happening a little bit better. But the mean value theorem, as long as you know that, technically you know Rolle's theorem. Okay, so the mean value theorem, we are no longer going to be at the same height, but we are going to talk about the slope between the 2 points. Okay, so please do not write anything down yet. I want you to just look at this picture with me. But what the mean value theorem says is that we have a curve and we have A and B. If we find the slope between A and B, then somewhere on the curve there will be a tangent line with that same slope. So there's going to be a derivative somewhere between A and B that has the same value as the slope between A and B. And you can see that visually where we have like those parallel lines. Okay. Go ahead and write it down. Well, it actually doesn't matter anymore about the y-coordinate, and I'll talk about in a little bit how this is, how Rolle's theorem is just a special case of this. What is a word that we have for derivative? We have a lot of words, but slope, average, instantaneous rate of change. What's a phrase that we have for slope? What's the phrase that we have for slope? Average rate of change. Okay? Basically, the mean value theorem says whatever the average rate of change is between the 2 points, somewhere between those 2 points there will be an instantaneous rate of change that is the same. Not necessarily. Not necessarily. Because if we have like this point here and this point up here, then it's probably going to be like more closer to here that would have that same slope. I don't say that that's the middle. Okay, it all depends on how the curve changes, like what the concavity is. Okay. Now let's think about if A and B have the same height, what is their average rate of change? 0. So Rolle's theorem is just a special case of the mean value theorem because the average rate of change is 0. So really, if we know the mean value theorem, we can apply it for Rolle. Okay. So go ahead and write down this function. F of x is x squared plus 2x minus 1, and we're going to talk about the interval from 0 to 1. If we're talking about the mean value theorem, we need to consider what the slope is between the 2 points, or what the average rate of change is. So in order to determine the slope, we need to know function values. Okay. What is f of 0? What is f of 1? Okay. So our slope is 2 minus -1 over 1 minus 0. Yes. Now, if we are trying to determine where the average rate of change is the same as the instantaneous rate of change, we still have to meet the stipulation of continuous and differentiable. Okay? So I know that, especially for a polynomial, it's going to be pretty easy. Are we continuous from 0 to 1? Are we differentiable from 0 to 1? Okay? So what we need to do is we need to find the derivative. Our derivative, Chris, what would it be? And we are concerned about where the derivative equals what? 3. And this time we're concerned about where it equals the slope, which is 3. Where does that happen? Where x equals 1/2. Okay. Yes, in this case, 1/2 is in the middle of our interval, but that's not going to be a thing that happens very often. On a parabola, our slopes are changing at a constant rate. because that might be doing it. All right, let's try another example. Okay, so we want to use the mean value theorem to find that value in the interval of 0 to 1 that meets the stipulations of the mean value theorem for x to the 2/3. So first, let us consider, okay, this isn't polynomial, so it isn't an automatic for us. Are we continuous on the closed interval and differentiable on the open interval? Are we continuous? Yes, we do not have any asymptotes or holes. This isn't rational. We don't have to think about that. Now, are we differentiable on the open interval 0 to 1?
Yes.
Where are we not differentiable? We are not differentiable at 0, but since 0 is an endpoint, that is okay. We need to be differentiable on the open interval. So not including 0, we are fine. Okay? All right, so for the mean value theorem, we need to calculate slope. Okay? We need the slope between 0 and 1. So first we need our function values. F of 0 is? F of 1? 1. That's kind of boring, right? What's our slope? Our slope is 1. Okay. Our derivative. Caroline, what would our derivative be?
2/3 x to the -1/3.
Good. And for the mean value theorem, we are concerned about where the derivative equals the slope between the 2 points, which in this case is 1. So I'm going to write it as 2 over 3x to the 1/3. And we want that to equal the slope between a and b, which is 1. How do we solve it? I don't really like having x in a denominator, so what should we do with it? Multiply x to the 1/3 over. Okay? I don't want x to the 1/3, I just want x. So what should we do to both sides? Cube both sides. So we have 8 over 27. Is that in our interval 0 to 1? Sure is. Okay, I want you to have a discussion at your table. Do you think that Rolle's theorem was discovered first or the mean value theorem? Yes. All right, how many of you think that Rolle's theorem came first? Mean value theorem. Okay, why do you think Rolle's theorem came first? Because it uses 0. Okay, I like it. Why do you think mean value theorem came first?
It's going to be easier to get Rolle's value than mean value.
Okay, because it's like the specific case.
And I feel like also back then when they were inventing math, everything's really complicated and they sort of got all the shortcuts later on.
Okay. Rosemary. Okay. Well, because it's the more specified version, right? Like, so I think that it's easier visually to see that if two functions have this, if two values have the same height, you know, we're gonna have to turn at least once, okay? Then, broader version, they figured out that they could prove v values here, okay? All valid arguments for both ways. Not essential to your learning of that. Okay, just wanted to. All right, so you have a homework assignment, and we have, are we in here till 59?
Yeah, we got done really early today.
Yeah, so how about you get 2 problems done before you leave?
Maybe that's why you're.
I have it next hour.